Hello students, welcome back to the physics class. In the last class we discussed about the system of units. Now in this class I am going to discuss about measurements. Measurements is very important in our daily life. For example, if you went to a grocery shop and you are purchasing some food items, then the shopkeeper will measure the food items which you are going to purchase with the help of a common balance. In that common balance, one side he will keep the standard weights which he had, on the other side he will keep the grocery items. So he will measure the weight of the grocery items with the help of the standard weights. So the weight can be measured with the help of another standard weights. So in the same way, if you went to a cloth shop to purchase some cloth or a cloth bit, so for that a shopkeeper will take a scale, he will measure the length of the cloth with the help of a scale, and he will measure the cloth whatever you require, or he will measure whatever the cloth you require. So here measurements is very important in our day-to-day life. Now we are going to discuss about the measurements of different quantities. So how the different quantities can be measured. Now in this concept, now I am going to discuss about the measurements of fundamental physical quantities like length, mass and time. So in that first I am going to discuss about measurement of length. Now length can be measured with the help of different measuring instruments like meter scale. So by using meter scale you can measure the length of a body. For example, I will take the line like this. I will take this point as A, I will take this point as B. Now how to measure the distance A begins? For example, take a scale, place 0 point of the scale here and you can measure the distance from A to B. Clear? For example, I will take a scale like this. So this B point touches which point on the scale, you can take that length as the length of the body. So by using scale you can measure the length of the body. Clear? So here we have a meter scale. I will show the meter scale here. So this is a meter scale. So by using this meter scale you can able to measure the length. Now in this meter scale we have 100 centimeters. Therefore by using this meter scale the maximum length you can measure is 100 centimeters. So by using this scale you can measure up to 100 centimeters. And what is the least measurement you can measure by using this scale means the least measurement you can use to measure the scale is, for example, this is 1 centimeter. Again in 1 centimeter we have 10 divisions. Therefore we have to measure, or we can measure 10 divisions of a centimeter. Clear? We can measure up to 10 divisions of a centimeter. So 10 divisions of a centimeter. Okay, so 10 division of a centimeter means 1 division is equal to 1 by 10 centimeter, that is 0.1 centimeter. So the least value you can measure by using this scale is 0.1 centimeter, or this is also taken as 1 mm. So the maximum distance you can measure with the help of this scale is 100 centimeter, and the least distance you can measure by using this scale is 0.1 centimeter or 1 mm. Or else you can express this like this also. 1 mm can be taken as 10 to the power of minus 3 meter to 1 meter. So by using the meter scale you can measure the distance up to 10 to the power of minus 3 to 1 meter. And we have another type of device that is called as vernier calipers. Vernier calipers. By using vernier calipers, we can measure the distance up to 10 to the power of minus 4 meter. Clear? Or else we can measure a least distance up to 10 to the power of minus 4 meter. Now this is a vernier calipers. Now by using this vernier calipers, you can measure the least distance up to 10 to the power of minus 4 meter. So in the same way, we have some other measuring instruments also. In the screw gauge is one of the measuring instruments. So by using the screw gauge, you can measure a least length or least distance of 10 to the power of 5 minus 5 meter. Now this is a screw gauge. So by using the screw gauge, you can able to measure a length up to 10 to the power of minus 5 meter. And we have another device also, that is called as spirometer. So by using spirometer, you can measure the least value of distance up to 10 to the power of minus 5 meter. Now this is a spirometer, so it consists of 4 legs, and one leg is a movable leg and 3 legs are fixed, and this is a rotating head. So this is a spirometer. So by using spirometer, you can measure the least distance up to 10 to the power of minus 5 meter. Now, what instruments or which instruments or which things will be helpful, which measuring instruments will be helpful if you want to measure very large distances, which is used to measure very large distances as well as very small lengths. Now, to measure very small lengths and very large distances, these instruments are not sufficient or it is not suitable. So, these measuring instruments are not suitable to measure very large distance or very small distance. So, in order to measure very large distance or very small distance, we have to go for some methods. I am going to teach about that methods now. So in that, first I am going to discuss about measurements of very large length. So measurements of very large lengths, or the very large distances cannot be measured directly from the, or cannot be measured with the help of measuring instruments like scale or vernier calipers or screws. So we can't measure the very large distance with the help of this screw gauge as well as vernier calipers or as this meter scale. In such cases, we have to follow few techniques. The techniques or method we have to follow to measure very large distances, parallax method. So to measure very large distances, we can use parallax method. Clear? We can use a parallax method. Now I am going to discuss about what is this parallax method and how to use this parallax method. Okay. For example, let us consider an object. Let us consider this as an object. Keep this object far from your eyes. Clear? Let us say keep this object far from your eyes. For example, first close your right eye and observe this object with your left eye. Then the distance measured from your left eye to the point P, I will take the distance as D. Now in the same way, close the left eye and observe this object with the right eye. Then the distance from your right eye to the point P can be measured. Clear? Or it is taken as, for example, D. So I will take this distance as D and I will take this distance as D. Now I will observe this object from two different observations. I will take my right eye as observation A and I will take my left eye as observation B. Now I observe this object from observation B and I observe this object from observation A. So I observe this object from two different observations A and B. So I will take this as, for example, a body which is very far, which is at very large distance. Now observe this body from one observation. I will take this observation as A and observe this object or body from another observation. Let us take this observation as, for example, B. So I will take this observation as A and I will take that observation as B. Now the two observation points are separated by some distance. This separation between the two observation points is called as basis. and this distance let us say B. For example, I observe this body from my left eye, from my right eye individually. Now the distance between this observation point to this observation point, so left eye to right eye, these two are the two observation points. The distance between two observation points I will consider as basis, or this is called as basis, and it is denoted with the letter B. And the distance from the right observation or the left observation point to the point P is taken as B, and the observation point B to point P, the distance is also taken as B. Now from that figure we can say, AP is equal to BP is equal to, that is capital D. From that figure you can say AB, what is that AB means? AB can be taken as basis. What is that basis distance means? I will take that as D. Now if you take the point P, at the point P the two distances from observation A and observation B make some angle. I will take that angle as theta. This angle is called as parallelic angle. Clear? So parallelic angle. So what is the angle between, clear, or angle P means, what is that angle P means? Angle P is theta, where angle P is taken as a parallelic angle. Clear? So this is taken as parallelic angle. I hope you understood. From this we can say, T is equal to, or else theta is equal to B by T. Clear? Theta is equal to B by T, or else D can be taken as B by theta. That is nothing but, if you take theta, this is the angle theta, opposite side of this theta divided by any one of this length. Clear? So therefore the distance can be measured. Clear? The distance can be measured by using this formula, that is B is equal to B by theta. Clear? That is B is equal to B by theta. For example, if you observe, or if you say this B, what is B means? Distance between the 2 points, which is very much less than, or this formula will be applicable when the distance between the 2 points is very much less than capital D. So what is capital D means? Capital D is the distance between A to P, or first observation point to the point P or the body P. What is this D means? This D is also nothing but the distance from second observation point to the body, that is taken as D. Now what is B means? B is nothing but the distance between two observation points, so I will take it as B. So B is very much less than D, or else B by D is much less than 1, then only we have to use this formula. Now by using this formula, how to measure the very large distances, I will tell you, just try to understand. For example, let us consider these 2 points are the 2 different points on the earth. Clear? Let us say these 2 points are the 2 different points on the earth. Now let us say this body as a distant star. Clear? Let us say this point as a distant star. Now this is a distant star. Clear? Now this is a distant star. For example, let us say this is 2 different points on the earth, or 2 different observation points on the earth. For example, I will take this as the surface of the earth, I will take this as point A, I will take this as point B. Now the distance from point A to point B can be measured. Clear? The distance from point A to point B can be measured, that can be taken as small b. Now we are going to find out the distant star, or distance for the distant star. I will take this as a distant star. Now from this, by using telescope, observe this particular star. I will take the distance as D. And you just move to the next observation point. What is that observation point means? B. Again by using the same telescope, observe this star. Now this distance is also taken as, for example, D. Clear? So observe this star from 2 different points on the earth. Clear? Now this angle theta can be measured with the help of the telescope. Clear? That angle theta can be measured with the help of the telescope. Therefore, with the help of the telescope, you can measure the angle theta, and we know the distance between 2 2 points on the earth, this point also we can measure. So we can measure the distance between 2 points on the earth and we can measure the angle theta. Then by substituting this value here, b by theta, then you will get the distance from point A to the star or point B to the star. I hope you understood. So by using telescope you can able to measure theta value. The distance between 2 points can be measured directly. Therefore you can substitute this value and this value. Then you can able to measure the other stars or planets or heavenly bodies. So this is measurement of very large distance or very large lengths. And next we are going to discuss about measurement of very small lengths. So the next method is, or the next one is measurement of very small distance. So as we discussed earlier, that is, the small distance can be measured with the help of screw gauge or vernier calipers or speedometer, like such type of instruments. But what if the distance is less than 10 to the power of minus 15 meter? Sorry, 10 to the power of minus 5 meter. If distance is less than 10 to the power of minus 5 meter, then these instruments are not suitable to measure the distance. Now at that time, we have to follow again some techniques to measure very small distance. So to measure very small distances, we are adopting a new technique. That technique is oleic acid method. So a simple method to measure small distances, clear, to measure small distances is oleic acid method. Clear, is oleic acid method. Clear, that is oleic acid method. Now in this oleic acid method, what we have to do is first to take 1 centimeter cube volume of the oleic acid. So this oleic acid volume is 1 centimeter cube. Clear, so I will take 1 centimeter cube of oleic acid. Clear, so first take 1 centimeter cube of oleic acid. Clear, first take 1 centimeter cube of oleic acid. Now it is going to mix with 20 meter cube or centimeter cube volume of, clear, 20 centimeter cube volume of alcohol. Clear, it is mixed with 20 centimeter cube volume of alcohol, and it is mixed with 20 centimeter cube, so 20 centimeter cube volume of alcohol. Clear, 20 centimeter cube volume of alcohol. Now what is the concentration of this oleic acid? Means now I take the concentration of this oleic acid as, so listen, I mix the one part or 1 centimeter cube of oleic acid into 20 centimeter cube of alcohol. Therefore concentration is 1 by 20 centimeter cube per centimeter cube. Clear, so this is the oleic acid concentration. Now after mixing these two, clear, after mixing these two, from this mixture, clear, from this mixture take 1 ml of, clear, or else 1 centimeter cube of again the oleic acid. Clear, now here oleic acid is mixed with, clear, here oleic acid is mixed with what? Alcohol. Again after mixing, again I will take 1 centimeter cube of this liquid. Clear, now the next part is again take, clear, again take 1 centimeter cube of this solution. Clear, and mixed with, clear, and again it is mixed with, clear, and again it is mixed with 20 centimeter cube of oleic acid, sorry, alcohol. Clear, the second step what we have to do means from this mixture again take 1 centimeter cube of oleic acid Again it is mixed with 20 centimeter cube of alcohol. Clear? 20 centimeter cube volume of alcohol. Clear? So I hope you understood this point. Now you have to do one more thing. What is that means? For example, take some lycopodium powder. So take some lycopodium powder. So sprinkle lycopodium powder on the water. Now take lycopodium powder. I will take another beaker. For example, this beaker consists of water. So take lycopodium powder and sprinkle lycopodium powder on the surface of water. Clear? Take lycopodium powder is sprinkled on water. Clear? Sprinkled on water. So take some lycopodium powder and sprinkle that lycopodium on the water. Then what will happen means this lycopodium water will sprinkle equally, or it will spreads. Clear? This lycopodium water will spreads. Now I will take one drop of, clear, I will take one drop of the oleic acid solution. So first what we did means we mixed 1 cube of oleic acid solution with the alcohol. Again we took the concentration as 1/20. From this again we took 1 centimeter cube. Again it is mixed with 120 centimeter cube of alcohol. Now what is the total concentration now is 1/20 into 20 centimeter cube. Now I will take this concentration of oleic acid. From this concentration I will take one drop. For example, take one drop. Clear? Take one drop of this solution. Clear? Take one drop of this solution and sprinkled on. Clear? Sprinkled on the water. Clear? And sprinkled on the water. Now listen. First we sprinkle the lycopodium powder. After sprinkling the lycopodium powder, you just sprinkle the one drop of this oleic acid solution. Clear? You just sprinkle one drop of this oleic acid solution. For example, if there are n water drops. Clear? For example, if there are n water drops. Clear? For example, if there are n water drops or else n drops. Clear? If there are n drops, I took only one drop. Clear? Take one drop of the solution sprinkled on the water. For example, if there are n drops, what is the volume means? Clear? The volume of oleic acid is. Clear? Volume of oleic acid is. Clear? Volume of oleic acid is n into V. Are you clear? So where V is the volume of each drop. Clear? Volume of each drop. I will take one drop. For one drop volume is V. If there are n drops of oleic acid, then what is the value means Nv. Now, if you sprinkle one drop on the surface of this water, clear? Now, before we sprinkled some lycopodium powder on the surface of water, later just drop one oleic acid drop, clear? One oleic acid drop on this surface of water. Then what will happen means, this oleic acid forms a circular cross section, or it forms a circular area. Clear? It forms a circular area on the surface of this water which is sprinkled with lycopodium powder. Are you clear? For example, if you drop this oleic acid, clear, I will take one drop of oleic acid. I will take this one drop of oleic acid from this concentration. Clear? I will take one drop of oleic acid from this concentration. So if I take one drop of oleic acid from this concentration and if I drop on this water surface, then what will happen means it will form a circular area of cross section. Now the area of this cross section can be measured. Clear? The area of cross section of that can be measured. From this area, we are going to find out the small thickness. Clear? From that area, we are going to find out small thickness by using one formula. Okay. Now, for example, what is the volume of the drop means Nv. Now, amount of oleic acid is. Clear? Amount of oleic acid is. What is the amount of oleic acid means? Remember, Nv is the volume of n drops, and what is the concentration of this oleic acid means 20 into 20. Clear? What is the concentration of that oleic acid means? Concentration of oleic acid is 20 into 20. Now, if you place the drop on the surface of water, clear, if we sprinkle drop of oleic acid on the water surface, clear, on the water surface, it will forms a circular patch or area on the surface of water, or it spreads in a circular area on the surface of water. Now that area can be measured, clear? So the area or the diameter, clear? If you find out the diameter, you can find out area. The diameter can be measured. The diameter can be measured, and from them you can find the, clear, from them we can find area. Clear, from there we can find area. Okay. Now from that we have one formula. Clear, from that we have one formula. What is that? Means thickness. Clear, thickness is equal to volume of oleic acid. Volume of oleic acid to the area. Clear, volume of oleic acid to the area of the film. Clear, of the film. Which means that it will forms a circular film on the surface of water. For example, if you take water surface and if you sprinkle a oleic acid drop, it will forms a circular film on the surface of water. Clear, it will forms a circular film on the surface of water. Now volume of the oleic acid, so how much volume of oleic acid we drop and the area of the film it forms. So the area of the film it forms, I will take it as, for example, A. Clear, the area of the film I will take like this. So area of the film it forms, I will take that area as A, and volume of the oleic acid is, this is volume of the oleic acid. Now from this you can able to find out the area directly, and if you divide volume by area, so we know that volume is equal to area into length divided by area, cancel these two. If you take volume by area, that will use the thickness. That will use the thickness of the film. Clear? That will use the thickness of the film. Now, thickness of the film can be taken as volume of oleic acid by area. So that can be taken as thickness is equal to, clear, thickness is equal to volume, that is NV into 1 by 20 into 20. That is the concentration by area is A. Then thickness T can be measured as NV by 20 into 20 into A. So this is the expression to find out the thickness of this thin film on the surface of water. Clear, thickness of the thin film on the surface of water. Now listen, for example, if the oleic acid forms only one layer, clear, if the oleic acid forms only one layer of molecules on the surface of water. Clear? If oleic acid forms only one layer of molecules on the surface of water, then thickness of the, clear, then thickness of the film gives the size of the molecule. Are you clear? So I will write that conclusion point at last. What is that means? If oleic acid, if oleic acid is if oleic acid forms a single layer on the surface of, clear, on the surface of water, clear, for example, if the oleic acid forms only single layer on the surface of water, clear, only single layer on the surface of water, then thickness of the film gives molecular size of, or size of the molecules of oleic acid. Then thickness of the film, then the thickness of the film gives size of the molecule. Clear, size of the oleic molecules. Clear, oleic acid molecules. So the size of this oleic acid molecules can be find out like this. Clear? The size of the oleic molecules can be find out like this. Clear? Now this is the expression for very small area or very small distances. Measurement of very small distances. Now I go for the different measurement ranges. Now I go for the next concept, that is different ranges. For PU examination point of view, this concept is important, and for one mark questions, these concepts or the questions from this concept can be asked, that is range of lengths. Clear? That is range of lengths. Remember, the least range of length I will take it as 1 Fermi. That 1 Fermi is equal to 10 to the power of minus 15 meter. This 1 Fermi is the size of nucleus. Clear? It is the size of nucleus. So size of nucleus is in the order of 1 Fermi. So 1 Fermi is equal to 10 to the power of minus 15 meter. So I am going to give few points for the ranges of lengths or few values. And similarly 1 angstrom. Clear? Similarly 1 angstrom. That 1 angstrom is equal to 10 to the power of minus 10 meter or 10 to the power of minus 8 centimeter. So this is the value of 1 angstrom. And similarly we have another unit for length, that is astronomical unit. 1 astronomical unit. So this is the large value of length. Clear? This is the large value of length. What is the astronomical unit of, astronomical unit means it is 1.496 into 10 to the power of 11 meters. Or else I'll take like this, 1.496 into 10 to the power of 8 kilometers. So that much length, that is 1 astronomical unit. And we have one more unit, that is 1 light year. This is 1 light year. So the distance from one planet to one planet or one planet to star and the heavenly bodies. For heavenly bodies, the distance is measured in either astronomical length or else 1 light years, or this is also called as astronomical unit. So what do you mean by light year means distance traveled by light in 1 year. Clear? Distance traveled by light in 1 year. So what do you mean by light year means distance traveled by light in 1 year. Now distance can be taken as speed into time. What is that speed means? That speed I will take it as speed of light, that is 3 into 10 to the power of 8 meters per second. So speed of light is 3 into 10 to the power of 8 meters per second. Time is nothing but 1 year. Therefore 365 days. Clear? That is 365 days. Okay. Now remember, actually always the time has to be measured in SI system of units. In SI system of units, time is measured in seconds. Therefore it is taken as 3 into 10 to the power of 8 into per 1 day. Clear? Per 1 day we have 86,400 seconds. Remember this value. Clear? 86,400 seconds. Therefore, if you multiply all these values, then you will get the answer as 9.46 into 10 to the power of 15 meter. So this is the light year. Clear? Which means that it is 9.46 into 10 to the power of 12 kilometer. Clear? So 9.46 into 10 to the power of 12 kilometer. And we have one more unit, that is parsec. Now this is also called as parallaxic second. So 1 parsec. So 1 parsec is equal to 3.08 into 10 to the power of 16 meter. So this is the value of 1 parsec. Clear? So this is the value of 1 parsec. Clear? Now these are the different ranges of lengths, and today I will conclude my concept up to here. So in the next video we are going to discuss about measurements of lengths. Thank you.